We're gonna talk about multi-threaded programming today, and multi-threading in Java is a feature that allows multiple threads to run concurrently within a single program. Threads are lightweight units of execution that share the same memory space and can communicate with each other. This makes a powerful tool for creating high-performance responsive application. We can create not only one threads in Java, also we can have multiple threads in our code. Let's give it an example of real life. If we suppose that we are using 2 tasks at a time on the computer, be it using Microsoft Word and listening to music, these 2 tasks are called processes. So you start typing in Word and at the same time start music app. This is called multitasking. Now you committed a mistake in a word and spell check shows exception. This means Word is a process that is broken down into sub-processes. Now if a machine is a dual core, then one process or task is being handled by one core and music is being handled by another core. We came across both multiprocessing and multi-threading. These are somehow indirectly used to achieve multitasking. In this way, the mechanism of dividing the task is called multi-threading, in which every process or task is called by a thread, where a thread is responsible for when to execute, when to stop, and how long to be in a waiting state. Hence, a thread is a smaller unit of processing, whereas multitasking is the process of executing multiple tasks at a time. So, multitasking is being achieved in 2 ways. First, we have multiprocessing. Process-based multitasking is a heavyweight process and occupies different address spaces in memory. And we have multithreading that we are going to talk about today. Thread-based multitasking is a lightweight process and occupies the same address space, hence while switching cost of communication will be very less. And we have below is life cycle of a thread being illustrated. We have new lifecycle runnable cases A, B, and running, blocked, and terminated. First, we have new, when a thread is just created, and second, runnable, we have when a start method is called of a thread processed by the thread scheduler. We have a case A can be a running thread, and case B cannot be a running thread. We have sleep, complete, EO, look, available, resume, notify, unnotify, runnable things, and non-runnable means blocked. It's case B. And running, when it hits case 1, when means the scheduler has selected it to be run, the thread from runnable state to run state, and blocked when it hits case 2, meaning the scheduler has selected not to allow a thread to change state from runnable to run. And last but not least, we have terminated, when the run method exists or stop method is called over a thread. Let's get into an example of creating and running threads in Java. And not only just create and run, we also can do it with, alternatively, we can create new thread by implementing runnable interface. Like, now, as I said before, we can use extends and implements. And let's call it like my runnable and runnable interface. And that's the same thing, that we have to create an instance of my runnable and create a thread and associate it with my runnable, so that we can get the output that we want, and we can synchronize and control access to shared resources. And when multiple threads are running concurrently, it is important to synchronize access to shared resources to prevent race condition and other synchronization issues. For example, here we opened a new public class counter, and we added the counter variable, and to increment the counter, uh, we use just synchronize keyword, and we can also use several built-in mechanisms for synchronizing access to shared resources, including the synchronize keyword, the lock interface, and atomic classes. For example, here we used lock interface, and you yeah and reintrant lock. So yeah, we can look it up here.